Hello everyone, today we're going to continue with modulus function. So let's do a little bit recap. What is modulus function? So the modulus of x written as the two bars around the x means that the size of x, and if we have the modulus of 5, that equals 5, and the modulus of -7 will equal to 7. So in our previous lesson, we have a complete table all by using the equation of the line. We have draw the graph for some simple modulus functions. So today we're going to look at some more of them. Right, so I think we have done those. This is the linear one, and we also, by the end of last lesson, we have done a quadratic one as well. Now we're going to look at this one. So we're going to sketch the graph of y equals to 3 minus 2 modulus of x. And to be able to sketch this graph, we need to use the rules of our transformations. And we're going to do them separately. So let's have a think. What is happening in this equation? So firstly, I've noticed is that I started basically with y equal to the modulus of x. And then I'll gradually make this equation look like the one we're looking for. So let's have a think how to draw the graph of y equals x. So in our previous lesson, I have mentioned that we could always draw the original one without the modulus sign and then basically reflect part of the branch which went below the x-axis. So for the first one, we know it's a diagonal line, so you go from 1, 1, 2, 2, and so on. So if I do my graph, and my grid has been squashed a little bit, so that's why it looks a little bit odd. Okay, now then normally I would have to continue into the left-hand side. However, we're taking the modulus, so that means at the point where it cuts the x-axis, I'm going to reflect this branch below upwards. So instead of going at -1, -1, it will go at -1, 1, -2, 2, and so on. So that's what your graph should look like. Okay, so the blue is the unreflected branch, red is the reflected branch. Okay, now next we're going to, so by looking at the original equation, we have a 2 of modulus x. So now we're going to times by 2. So think about transformation. If we times by 2 to basically the entire function, not directly happening to x, multiply by 2 here means that we have a stretch. So it will be a stretch in the vertical direction with scale factor 2. And what that means is your x-coordinate stays the same, but your y-coordinate will all get doubled so that your graph will get pulled upwards. Okay, so let's have a think. Now we can basically identify some points. So 0, 0 still stay the same because we have times by 2, nothing changed. However, before we had a 1, 1, now the y value had doubled, so now become 1, 2. Before we had a 2, 2, double the y value, so be 2, 4. And then we continue, so 3, before we have 3, 3, now double the y, so it becomes 3, 6, and so on. You can see where we're going with our graph. Okay, and basically again, we could have the part of the graph go below the x-axis, but now we're going to reflect it upwards at the point 0, 0. So now it will go at -1, 2, -2, double the y, so be -2, 4. So look like that. Okay. Right, then we're going to build upon that because in my equation now I have a negative sign in front. So let's have a think. What is y equals to -2 modulus of x. So when we put a negative sign into the entire equation, it's not affecting the x value, so that means it will be a reflection. And since basically before it's above the x-axis, now it gets flipped down. So it's a reflection along the x-axis. Okay, so that means if you look at the blue line, maybe I should use this one. Yes, so the blue line here now get reflected downwards, same as the red line. So now you have to go through 1 minus 2, 2 minus 4, and so on. And the red part do a similar thing. So now before you add minus 1, 2, now it become minus 1, minus 2, minus 2, minus 4. So that's what the graph will look like. Okay. Now, some people may say, oh, well, why would we have a modulus function for this one? The graph actually goes below the x-axis. That is simply because the negative sign is outside of your modulus symbol rather inside. Okay. Right. Finally, to make look like the equation I'm looking for, I have a 3 here, which means I need to add on 3. And add on 3 to the entire equation, that means it's a translation. So let me write down. Okay, so this will be a translation with vector. So add 3 to the entire equation means it's in the y direction. Nothing's happening in x direction. I do want to add a 3. So add 3 means the whole graph gets shifted upwards by 3 spaces. So if you look at the tip of this shape before the 0, 0, now is going to get moved up by 0, 3. So now it becomes 0, 3. Now I need to move down so you can see the grid. Okay, so right, so 0, 3 is here. And then the other point before at 1 minus 2, minus 2 out of 3 will be 1. So now it'll be at 0, 1. And so on. So basically, after you identify a couple of them, you'll very quickly be able to identify the rest of your point or the graph. Okay, now let's do the reflected branch. So now before it's at minus 1, 2. So sorry, minus 1, minus 2, minus 2 plus 3, that becomes 1. So now at minus 1, 1, and so on. So that's your final graph for that modulus function. Okay. Right. So for this one, instead of letting you do it because I won't be able to check it properly, I'd like you to have a think about how we're finding the vertex of this V shape. So I don't know if you remember in our previous lesson, we said to find the vertex, or in other words, where does your graph cut the x-axis? Okay, so to find that, we basically need to let our y equal 0. And then you would solve your equation to work out the x value. And this x value will become the x coordinate of the vertex. So any point, any part of the graph afterwards, if it's down below, it has to get reflected upwards. Okay, so here is basically a summarize of the rule. Okay, so if you have the graph with modulus function y equals to ax plus b, and it has a V shape with a vertex at basically you try to make this equal to 0. So really we have ax plus b equal to 0, and you want to obviously make x a subject. So we have ax equals minus b, and x equals minus b over a. So that becomes the x coordinate. Okay. Right. So you need to quickly copy this down, and also you can copy down where does the graph cuts the y-axis as well. So after you've done that, I'd like you to complete exercise 3b, question 1 and 2, please. Those questions will be in that pack of worksheet I gave it to you yesterday. So please find it and the answer printed at the back of your sheets. All right. Now, next, after you've done a little bit of practice, we can move on and look at something else. Okay. So this is about modulus notations in inequality. So the modulus inequality of x minus a less than b is equivalent to x is greater than a minus b, but also x has to be less than a plus b. So here we have done it as a combined kind of inequality, but of course you can split it. If you do want to split it, you will then end up with x minus a is less than b, and then the other side we will have our x minus a. We have to swap the sign, which has to be greater than, and then change the sign of b, so it has to be minus b. So you can split them, or you just do it this way. So let's have a look at an example. So part A, write the inequality, the modulus of x plus 4 and less than 6 in the inequality form. So we can compare the formula with our equation. So the formula says if you have x minus a, the modulus of x minus a less than b, I can rewrite it as x is greater than a minus b, but also less than a plus b. So for part A, you've been given that the modulus of x plus 4 is less than 6. So then you can very quickly identify your a and b. So a will equal to minus 4, and b will equal to 6. And then we can, well, I was going to say perhaps we can substitute back in. Oh, yes, we can. So we can substitute back in here. So now we have minus 4 minus 6, which is less than x, and x is less than a plus b, so b minus 4 plus 6. So that means now if we simplify, our x will have to be greater than minus 10, but less than 2. Okay? And finally, write the interval minus 3, 7. So this is a quick recap of your interval notation. Minus 3, 7 with a square bracket means your inequality has to start at minus 3, including minus 3, and then stop at 7 and including 7. Okay, so that's what this means. Right, now the next thing is we have to find, so here it says find this form modulus of x minus a is less or equals to b. Right, so again, we could use this formula. Okay, now what I do know is that this inequality notation, you know what, I'll start another page. So this inequality notation, I can rewrite it as x is bigger than minus 3 but less than 7. Okay, and what do we need to find? Write down the interval using inequality of the form. Okay, so really we have to identify our a, b. So by looking at the formula, well, here I have the equal sign, so we can basically put equal sign into our inequality. Okay, so from this modulus inequality, I can end up with this inequality. So now I know that for my x, what did it say, minus a, which is no, sorry, I don't know where I got b. So I have the modulus of x minus a less than b, and it's equivalent to x is greater than a minus b, and x has to be smaller than a plus b. Okay, so by comparing the inequality and what we have here from the formula, I can straight away notice that the left-hand side, your a minus b must equal to minus 3. The right-hand side, a plus b, must equal to minus 7. So here now we end up with a simultaneous equation to solve. And you can see the numbers are quite straightforward. So really what I can do is simply add 1 and 2 together. And then the minus b and b will kind of disappear. So now we have 2a equals to minus 3 plus 7, that is 4. So it means a equals to 2. And then you can substitute a equals 2 into any of those equations. So let's say I'm going to put in equation 2. So now I have, so if a plus b equals 7, a is 2. So now I have 2 plus b equals 7, which means b must be 5. So now I can then put it back into the modulus function. So now I have x minus a, so minus 2, and it has to be less than 5. And that's our final answer. Right. Okay, so after this question, I would like you now to complete the remaining of your exercise 3b, please. So question 3 up to question 8. Please remember the answers are printed at the back of the sheet.